Today I want to discuss tubular bundle heat exchangers. You'll say, finally, you always talk plate exchangers. I am aware plate heat exchangers have always intrigued me. However, there are certain scenarios where the plate heat exchanger is unable to handle it completely. I desired to converse regarding tubular bundle heat exchangers employed in cogeneration. You genuinely hear a substantial amount of information about cogeneration. And I believe it will definitely be the topic of one of the upcoming videos. We will talk about it in a very in-depth way because it is an interesting topic. Cogeneration enables the simultaneous production of thermal energy and electrical energy by cogenerating, as the term itself suggests. It allows for the efficient generation of both forms of energy. But let's get back to us. Let's talk about shell and tube heat exchangers. One of the recoveries typically done in cogeneration plants is the recovery from exhaust fumes of engines. Cogeneration plants are generally made up of a diesel or gas endothermic engine that is used to generate power for an electric generator, typically through the process of cogeneration. The generator produces electric current and the engine exploits thermal energy. That is, the heat generated by the engine is recovered through the use of an endothermic process. We all know that our cars have a radiator that helps to dissipate the heat that is generated by the engine. Otherwise, the engine would overheat and could no longer function properly. What are you doing? Hot water circulating in the engine is taken, which then heats up. It is passed through a heat exchanger, in this case a plate heat exchanger, and that energy is recovered by producing more hot water. However, an endothermic engine generates additional heat, which is produced by the exhaust fumes. This heat constitutes a significant percentage of the total heat generated and is deserving of recovery. Moreover, the exhaust fumes reach high temperatures, typically ranging from 600 to 650 degrees Celsius, making it imperative to utilize a tubular bundle heat exchanger for this purpose. They are very specific exchangers, typically with tubular bundles with straight brushable tubes. Why? Because even though the fumes are clean, they always contain a small amount of combustion dust, a small amount of combustion particles, and therefore they need to be cleaned from time to time. So they are designed with straight brushable pipes, an outer shell, and are usually made of stainless steel. Why? Especially the two heads and the tubes. Why? Because combustion fumes, whether they are from diesel, biogas, methane, can contain acidic elements that corrode the material of the heat exchanger, especially when operating at high temperatures. As a result, these heat exchangers are definitely made of stainless steel for the part in contact with the fumes. The outer part, or mantle, can be constructed using carbon steel. You need to exercise caution as this type of construction necessitates specific safety measures. For example, all the tubes are welded and chamfered on the headers. It is not enough to just tighten the fittings because thermal expansions could lead to a detachment of the pipe from the head and therefore leaks. An expansion joint is typically installed on the cloak. Why? The reason is that water is usually passed through the cloak to recover energy and to be heated, as the water is at much lower temperatures compared to the desired heating temperature. Let's say it can reach 90 degrees, great. With the fumes at 600, you understand that the difference in expansion between the mantle and the pipes is very high. Therefore, it is definitely necessary to install an expansion joint. In previous times, detachable headers were utilized, which could be made of either carbon steel or stainless steel. They were also commonly manufactured using high-thickness carbon steel because of their low replacement cost and the capability to easily eliminate them when needed. Currently, the headers are almost always eliminated in favor of pipes directly from the exhaust to the muffler, also because these pipes have a very low replacement cost in case they corrode or get damaged. They certainly cost less than a header, and consequently, when maintenance is done or there are leaks, all that needs to be done is to replace the eventual corroded or damaged pipe. This is an interesting topic, isn't it? It's fascinating how the use of pipes instead of headers can provide cost-effective solutions for maintenance and repair in automotive exhaust systems.